Hello and welcome back. This video is going to be on direct proofs, and it's going to be a first of a 3 or 4 sequence video series on how to do mathematical proofs. So what a direct proof is you are given a hypothesis and a conclusion, and you are asked to prove the theorem in either a direct proof, an indirect proof. It depends what is being asked for, but this video is on direct proofs only. So how a direct proof is set up is you are going to first assume the hypothesis. Okay, so you're going to do that, and then you have the body of the proof, which is an explanation, and it involves different parts, and we'll go over that a little later. And then you're going to state the conclusion of the proof. So, and then you cannot forget your little block at the end to make the proof correct, and it is oftentimes referred to as a tombstone. And you also should write PF, it stands for proof, at the beginning. And in order to do any kind of proof, we need to understand this remark, and I'll read it for you and then I'll explain it more in depth. An integer n is even if and only if there exists an integer such that n equals 2k. N is odd if and only if there exists an integer such that n equals 2k plus 1. Okay? And, before I go over this, I'm going to go over some mathematical symbols that are oftentimes used in math proofs. So this backwards capitalized E means there exists. IFF means if and only if. And this weird looking E means such that, and it's written usually like it looks like a subscript partially below the line of the text, like I did here. Okay, so back to this. So when you say that n equals 2k, that is assuming that n is even, because guess what, any even number is divisible by 2, so therefore that makes n even. So essentially n, we're saying n is k, but it's being divided by 2, if that makes sense. And then n is odd if n equals 2k plus 1, because if we have any even number and add 1 to it, that makes it odd. So if we have 2 plus 1, that makes it 3. If we have 16 plus 1, that makes it 17. And both 3 and 17 are odd numbers. So that's definitely something to keep in mind as we work through these proofs. And here I have an example. Okay, so we're given the theorem. First we have, let me get another marker here. Okay, so we have if f and n are even integers, then m plus n is an even integer. So what is the hypothesis here? Well, the hypothesis is m and n are even integers. That is what we are trying to prove. Okay, so we're first assuming the hypothesis, then we have the body, then the conclusion. The conclusion should be that m plus n is an even integer. So that's what we need to end with. Okay, so we have the hypothesis and the conclusion. Okay, so what did we say first? First, we're going to assume the hypothesis. So we're going to assume that m plus and n are even integers. Okay, so that's the first part. Now we have the body. Now the body is a little bit tricky. It's basically a matter of memorization and logic put together. And also these proofs are, they're hard to understand once you first learn them, but with practice you will understand them a lot easier. Okay, so now we have the body. So now we have to say, then there exist, and I'll use that symbol, integers j and k such that n equals 2j and n or m equals 2k. All right, so now we've just stated that n is an even number and m is an even number, just like it says in the hypothesis. Okay, so now we have thus m plus n equals 2j plus 2k. Okay, so now we're getting into the conclusion. What are we trying to get at? We're trying to get at that m plus n is even. So now we're going to state m plus n, just like we had from the previous line. And now if we take a closer look, we can factor out a 2. So 2 times j plus k. And look at that. What did we say from the remark from the previous sheet of paper? We said that 2 times any number is even. So we just proved that m plus n is even when m and n are even. So now we have the conclusion. Therefore, m plus n is even. And then let's not forget our tombstone. Okay, that's all, really. So just with practice, you will start to know the ropes of how to do these proofs. And I'll see you next time with a video on indirect proofs.